So we're going to look at how to use the software graph to look at the continuity of a piecewise defined function. So I've used my text feature or label feature here to define for us a piecewise function that we want to look at. So our piecewise function is negative x plus 1 if x is less than 1, and negative x squared plus 4x minus 3 if x is greater than or equal to 1. So what I need to do to graph this piecewise function is I'm going to click on function and I'm going to insert a function. I'm going to insert one of the two pieces. It doesn't matter which one I do first. I think we shall do the negative x plus 1 function first. Now notice that I only use that for values of x less than 1. So here in my argument range, there's no real starting from value, but it only goes up to 1. Now, if we look at our definition here, it does not include the value at 1. So I'm going to end my graph with an open circle. Now I'll go ahead and click OK. And that's what the first piece looks like. I'm going to go ahead and scoot this up over here into this corner so that we can now look at the second piece. So now we want to graph the second piece. So I'm going to insert a function again. And I'm going to scoot this over so I can see what I'm doing. And the second piece is negative x squared plus 4x minus 3. Now that's my function, but I only want to use this function for values of x bigger than 1. So we start using this piece of the function when x is 1 or bigger. So the argument starts, or x starts at 1, but goes on forever. So that it starts at 1, but goes on. So I don't have any 2 value here. Now also notice in our definition here of our piecewise function that x has a possibility of equaling 1. So whereas before I had an open circle on the first piece, I'm going to have a closed circle for the second piece. So I'm going to select an endpoint of a closed circle, and I'm going to click OK. And now I have both pieces of my function graphed. So now that I have the graph of my piecewise function, I can determine whether or not it is a continuous function. And looking at this, I can easily see that I could indeed draw this graph without ever lifting my pencil. But that is not what the definition of continuity says. And we want to explain why this is continuous based on the definition of continuity. So I've written up here an explanation of why this is continuous. So first of all, this piecewise function is continuous because both pieces are polynomials. Notice the first piece, negative x plus 1, was a line. The second piece was a quadratic or a parabola, which means they are both continuous on their domain. So this first piece was continuous when x was less than 1. This second piece was continuous provided x was greater than 1. The only place this function could be discontinuous is where we join the two pieces together. That's at x equals 1. So for this function, if we're using the definition of continuity, then the first part of continuity is that at 1 the function is defined, and our function is defined at 1. That's the second piece, is where it's defined at 1, and it actually equals 0. The second part of the definition of continuity is that the limit is defined as at this point where we piece them together. So if I think about the limit from the left, I get 0, and the limit from the right also produces 0. So the limit exists for this particular function and is actually equal to 0. Now the third condition is that these number 1 and number 2 have to produce the same number. Number 1 says that f of 1 is equal to 0. Number 2 says that the limit is equal to 0. And this is where we piece together the idea that the limit of f of x as x approaches 1 is actually equal to f at 1. So I get 0 equals 0. So therefore, my function is continuous.